Hey everyone, sorry for the delay in getting you this video. A lot of you guys in the comment section in the previous video about this specific AliExpress inverter wanted to see the waveform that this thing produces while it was under load. I've been busy with a bunch of other projects, so I haven't had the time to dedicate to doing this test for you, and I feel bad. A lot of you have asked for it. And to be totally honest, I actually really want to see myself. So that's what we're going to be testing here today, is to see what the waveform, this pure sine wave, hopefully it's pure sine wave. We're going to see what that looks like when it's under load. So I've got kind of a cool test here today. I've got a bunch of just small utility batteries. And what I'm going to do is we're going to hook this inverter up to those utility batteries. I'm going to connect this into my garage, which I have, the capability of making it off-grid for short periods if I like. So I'm going to connect this into my garage, and we're going to power everything in my garage. The fridge, my computer, my screens, stereo, all of the lights in here, everything in general. So we're going to see what that looks like. I can turn a bunch of things on at different times in order to change the load that we put on this thing. I'll measure the current, the DC current coming in, and then I have a power meter. We're going to measure the power that's coming out of this thing. And as well, I'm going to hook up my oscilloscope, and we're going to see what the waveform looks like under various stages of load. So the batteries are small, so hopefully we can make them last long enough to do this test, but I think it's going to turn out really good, and let's see what this thing can do. So I got my inverter roughly mounted here, and here is my battery setup. So we got my 12 volt cabling attached there, and we'll just follow that over. And so I have one terminal connected here, and then my negative terminal connected here. I have 4 of these batteries, 1, 2, 3, and 4, all connected in parallel. So this inverter you guys have seen. Here is my watt meter, Home Depot special, whatever. I bought this a long time ago. So on the AC side here, plug my watt meter in, and this is how I'm going to measure the wattage coming out, or the power, amperage, everything. And we will plug this in. What I did here is I've created the forbidden cord. This cord, it's just a piece of 12 gauge wire with 2 male ends. And the reason I call this the forbidden cord is because if you don't know what you're doing, you can blow some stuff up. You create a very dangerous situation for yourself. So anyways, this forbidden cord we are going to use though. And what I'm going to do is I'm going to plug one end into the inverter, or into the watt meter, and then I'm going to plug the other end into this receptacle right here. And what that's going to do is it's going to backfeed through my whole garage. Please excuse the crudeness of the wiring in this garage. I just needed it to work. Okay, now I got everything hooked up. That took a while. So like I said, we still got 12 volts in to the inverter here. Now same setup as before, more or less. So this white wire here is feeding the hot and the neutral from the inverter itself, which once again is feeding my doorbell transformer. And then we've got roughly 20 volts or so coming out of the transformer and going into my oscilloscope. So we'll just let that thing boot up. So if I click on my inverter like I just did, there you go, you see that same waveform as before. And so once again, I'm just into the doorbell transformer, which is coming out of here. This thing is cobbled together, but I have a good idea what I'm doing. So anyways, once again, it's hooked up with all these batteries. And I have, again, my forbidden plug, and I'm not going to touch any of that because that is live right now with 120 volts. Because I shouldn't have been leaving it dangling down there. But anyways, that is live with 120 volts currently. So I'm going to shut off the inverter. All right, so I got everything coiled up here. I'm going to leave that right as is. The inverter is currently shut off. And what I'm going to do is I'm going to do this all in one take so you guys can see that the power to my garage is actually shut off, and then I can start backfeeding in through the inverter. So again, we're going to take this connector here, which is connected through this yellow cord into my watt meter, which then goes through this little doubler thing, which is a little loose. I have to fix that, but for now it'll work. Anyways, and we're going to connect that to my doorbell transformer into my oscilloscope, and we're going to pull all that power from the batteries. Once we get this set up, then I'll measure some current, I'll measure the wattage, and you guys can see, and we'll take a look at the sine wave and see what it looks like. All right, here's my disaster. Here's my cord. Here is my inverter. All right, come with me. This is all in one take. So there's that end. I'm gonna walk over and shut off the disconnect for my garage. So this is all in one take, and you guys get the full view of this disaster. Anyways, all right, so I'm just going to turn this around. You can see this disconnect, which I've already left my light over here for, and you'll be able to see in a second when I pull this. Obviously the power is going to go out in the garage. I'll show you inside this disconnect. It's disconnecting the hot and the neutral in this garage, so we should be able to backfeed everywhere into the garage and have no worry of any of that backfeed going back into the house. So let's try it out. So I'll do it all in one take. So it's gonna get dark. 3, 2, 1. Oh, there we go. Here I am. Here is that disconnect, and I'm just gonna show you all in one take. So I'm gonna flip my camera around, open this. Pretty straightforward stuff. A couple of 20 amp fuses. Anyways, whole garage is dead. So I'm gonna work my way back over and try not to trip on anything. All right, so back to my forbidden cord, and we're just gonna plug this forbidden cord in. Trying to decide if you can see that. Yes, you can. All right. Now, I'm going to kick the inverter on. And we're back in business in this garage, which is awesome. All right, so you can see, obviously, as soon as I turned the inverter on, I know it was hard to see because it was dark, but the whole garage came back on. I have all my lights, all of my power, even my classic 1947 Frigidaire fridge is powered back up. Surprisingly efficient. I'll do another video on that. Anyways, let's take some readings. All right, so currently out of my inverter, it is running. It's producing 120 volts or 112 volts at 60 hertz. So let's just take a quick little look at my waveform. Hey, look at that. It's pretty solid. So let's take a look at our wattage. Sorry, I'll just leave it on the side. Currently drawing 2 amps in this garage right now. A total of 220 watts. Some small variation here. What else we got here? Our total, or our max wattage was 248 watts drawn so far. We have currently not used a single kilowatt hour. And if I wanted to, I could put prices and dollars and stuff like that in here, but I'm not doing that. So there we are, back to 112 volts. So we're using 200 watts of mixed power right now, and still have a fairly solid waveform between 59 and 63 hertz. And interestingly enough, it bounced around the same under no load whatsoever. So again, we'll follow this black cord that runs to these 2 leads connected to the doorbell transformer. The doorbell transformer then is this white wire that connects to this power block that connects to my inverter itself. You can see it's reading battery voltage. We'll take a reading on the batteries themselves and see if that's accurate in a minute. But again, aside from that, we're using 2.01 amps, and right now about 226 watts, which is all of these fluorescent lights, a couple of LEDs, Small set of Christmas lights. My stereo in the background, which is on, but it's not currently making any noise. And yeah, a little bit of everything. All right, I got my Fluke clamp meter here, and it measures both AC and DC amperage. So we're gonna take some amperage readings first. So I'm gonna kick it on. I'm gonna go to DC. We are gonna measure the amperage that this inverter is currently pulling from our battery setup. So I'm just going to clamp that on, and it looks like right now we are drawing about 22.4 amps from our batteries. So we should be able to test that on both positive and negative, and have it roughly be the same, just negative. And about 22.5 amps we're pulling from these batteries in order to make 200 watts. So kind of interesting, the voltage meter here on the inverter itself is reading about 11.5, 11.6, but I have a couple of test leads on here and I am actually measuring 11.9. So there's a little bit of a voltage discrepancy between, I kind of trust this Fluke meter a little more than I trust the voltage reading on the inverter itself, but I'm still fairly satisfied that this inverter is going to shut down at the right voltage. It might be a little bit premature, but to be honest, with these old utility batteries I'm using, I don't actually have a problem with that. And once again, nice sine wave powering everything currently in this garage. All right, well, interestingly enough, my fridge tried to kick on, and sometimes it draws a pretty heavy current when it starts. Again, it's 1947, so can't really say that's surprising. Anyways, it must have drawn more than the inverter could handle all in one shot. And to be honest, it's probably the batteries that are the issue because they're not the right capacity. So that's the inverter you hear beeping in the background. But it drew a little bit more current than the inverter could dish out based on the battery voltage that it had going into it, and everything shut down. So that's kind of an interesting thing. I didn't get a chance to see what the current level was that it actually pulled before it died. I can't even tell you what that current draw was. Go figure, I walked away for a minute and it tripped. So anyways, I'll get back in a second after I get everything fired back up. Okay, so we got the garage back hooked up to the grid, but that's fine. I just wanted to show that it can be done. If I had some better batteries, we would be probably still running off of batteries. But anyways, a few of you asked in the comments if I could run a power tool with this and what the sine wave would look like. I'll hook up a drill to this inverter and we'll see what the sine wave looks like under load. I want to see what that sine wave looks like with a corded drill plugged into it. And again, we'll see what kind of wattage this can use. I currently am using 0.06 amps, which is nothing really, but 5, 6, 7 watts. And interestingly, so I changed my setup a little bit so I could plug this drill in a little easier. And so as of now, the only thing using 6 watts is actually this doorbell transformer. So it's just using a little bit of power. But there's our sine wave. So again, I didn't change anything in the setup, but what I did add here was a corded drill. So I'm going to leave the drill running and we'll go straight over to my sine wave, and a little ripple there. There's a little ripple there, but it actually doesn't break down too bad. So if we go to wattage, again with the corded drill, you can see what kind of power we can pull. So about 278 watts. So I can add another little load to this thing and we can check the sine wave again. Maybe we'll get this thing up to 500 or 600 watts total power. All right, so somebody at one point asked for a pure resistive load. So I have 652 watts, 650 watts right now. See, my voltage has dropped right off at 10.5 volts. So let's take a quick look here at what I got. So if we follow this black cord down, I actually am running an electric heater, and it is producing heat. So we'll take another look at the sine wave, and look at that. We're still right on the money. Not much has changed. So because of my voltage is pretty low right now because I'm running an electric heater off of batteries. So I am running the electric heater currently, and I am drawing 69 amps from these 4 batteries right here. That is a lot of current. Doesn't make much sense to run an electric heater with one of these inverters. But again, that is still a nice clean sine wave. You know, I thought just for the heck of it, we got the heater. Got almost 800 watts, and that's still a pretty reasonable sine wave. Oh, except our battery voltage dropped, and it shut off. But that's all right. All right, so hopefully those tests that we ran give you a better indication on, you know, a little bit of this thing's performance. You know, it would have been nice to see this thing make up to 1500 watts, but to be honest, my batteries are a bit small. You know, it would help if they had a constant charge going into them as well. I do plan on pairing those, maybe some different batteries, with some solar panels at some point in time. You know, bringing that battery voltage up throughout the course of the day, which will help this thing as well. It will keep the voltage boosted a little bit and sort of level things out. If we're putting current in, we're drawing less current from the batteries themselves and more from the solar panels and the batteries. So anyways, so yeah, overall, my impressions of this thing are actually surprisingly good. You know, we saw up to the 700, 800 watt range that we pulled off of this thing, and that was a mixed load. So, you know, for a very short period, we ran both an electric heater, which I don't know what you would ever want to do with one of these things anyways, but we ran both an electric heater and a cordless drill for a short period. So, I mean, and the waveform stayed pretty steady. So, overall, I am pretty happy with their pure sine wave, you know, rating for this thing. So I do have some little issues with the accuracy of this voltage meter. You know, it was a few volts off, which could skew things a little bit. It could make it shut down prematurely. Obviously, we saw that a couple times. So it wasn't this that was causing this to shut down, but ultimately, you know, the low battery voltage is one of the biggest things. Those are old batteries. They were small capacity. Each one of them is only 16 amp hours anyway, so I have a really small battery bank. I just use them for kind of playing around. Anyways, overall, I'm fairly happy with this. If you wanted to put something like this, you know, for $100 or $130 or whatever it is now, it's nearly a year later. If you wanted to put something like this in a vehicle, and, you know, keep an alternator, you know, with the vehicle running, the alternator continuously charging the batteries. This thing, I'm sure, could run all kinds of stuff in a vehicle. Easily run microwaves. I'd be satisfied with that. Microwaves, fans, you know, power tools if you're stopped. You know, this, I can see something like this being really useful for service vehicles, right, that you need 120 volts on the go. Again, because it's a pure sine wave inverter, it's good for power tools and things like that. But, you know, other people, you know, talk about its size, and it doesn't really look like 3,000 watts. I do have a tendency to agree. Unfortunately, I'm not that well equipped to be able to test this thing to its full potential. But ultimately, you know, like I said, we saw this thing produce, you know, 700 or 800 watts. You know, not continuous, but long enough that I think we get a good idea of what kind of sine wave it produces. And that was the ultimate goal of this test, was just to see if this thing could withstand any kind of load. So I hope you guys are happy with that. I know I'm actually happy with this. For $100, this thing can do what I need it to do, and especially if I couple this, you know, with some solar panels, you know, a couple solar panels maybe wired in parallel to boost the current into a charge controller, which will ultimately boost the battery current and, you know, take some of the load off of the batteries themselves, and ultimately keep this inverter up and running. That's my ultimate goal, is to try and do some off-grid stuff, just playing around with my garage itself, because it is detached from my house and I have a nice sunny side. I can kind of play. Now, one of the things, you know, worth considering, one of the things I would do differently is probably not buy a 12-volt inverter. There was other options on AliExpress. I could have got 24-volt. I could even got a 48-volt DC input on basically the same inverter. The nice thing about that in going with a higher voltage is that you reduce the current level that you're drawing from the batteries every time. So you can actually build a you know, a 24 or 48-volt battery bank, and when you use a 48-volt battery bank versus a 12-volt battery bank, the current you're drawing, that's one of the things I would consider doing. But there's obviously some other drawbacks to that as well. If I went with a 48-volt inverter, it would be stuck in this garage and I'd never be able to use it in a vehicle. It required a lot of other, you know, components to make it work. Not something I wanted to get into. Keeping it 12-volt makes it very usable and very flexible for anything I want to do. But again, the downside is that the current level I draw is going to be that much higher compared to the 48-volt. Something to consider. So, anyways, thank you very much again for sticking with me. I know this has been a long journey, better part of a year in order for me to create a response, and I do apologize for that. Got a lot of things on the go, you know, house, kids, wife, family, full-time job, lots of travel, and you know, it's not always possible to make these things the moment you guys want to see them. Again, thanks for sticking with me. Hopefully you did find this informative. If you like this video, you know, go ahead and you know, hit like for the video. Feel free to subscribe. I'm going to try and post some cool content. I'm into all kinds of stuff. You know, I'm an automotive mechanic by trade, working through an electrician's apprenticeship. I work in renewable energy. For the last 14 years, I've worked in both wind power and solar now, and I do a lot of training within the company. It's kind of my specialty now. So, you know, if you like my videos, you know, feel free to subscribe. If you have any suggestions for cool videos that you want to see in the future, like I said, I'm kind of into everything. So, you know, if it has an engine, if it has electricity attached to it, or if it's anything renewable energy, I'm interested. That's my life, basically. If anyone is interested in purchasing either one of these, I am in no way, shape, or form sponsored by AliExpress. I just like cheap stuff and messing around. But I will post the links to both the oscilloscope as well as the inverter in the comment section or in the description below. So please check those out if you're interested. I believe they're both still for sale, even though I bought them more than a year ago. So feel free to check them out and take a look at some of the other different options you can get with some of these different pieces of equipment. Anyways, thanks for sticking around. Thanks for sticking with me. I'll try and roll some videos out a little more often. But again, hit like, hit subscribe if you like my channel, and don't forget to hit that little bell icon for the notifications. So every time I post a new video, you'll get a notification. Anyways, thanks again. We'll talk soon.